Hey everybody, we're going to talk about making a window today. Pretty simple thing. I'll also try to go over a little bit of MATLAB, but it should mostly be in the first tutorial. So what I did was I'm in my home directory. This is all my files in my home directory. I can change directory into my this year's 257 folder, and I have sine tone. So what I did to launch MATLAB was type MATLAB and put an ampersand at the end so it didn't lock up the screen. And this opened MATLAB. Now, what some of you might be having trouble with is that if you're on a Mac like I am, the new Mac OS does not come with X11, which as you see is the application that gives me the graphical user interfaces. So I sent out a link to download Xquartz, and that will help you getting this interface. To look at the interface, we have where I am in the Karma system, the files in the folder. These are the variables I have stored right now. If you guys haven't worked with program before, variables can be anything. They can be strings, which are basically words. Made of characters, frequency, or we have integers, which are just whole numbers. There are things called doubles, which are numbers with decimal places, and then vectors. So this is a time vector is a 1 by 1 row, 44 1 and 101 column vector of doubles of floating point numbers, which basically means numbers that have a decimal place. Yeah, so to go over it a little bit again, if we wanted to go over some multiplication and addition stuff, so if I set something to be 5, it's going to be a vector, as you can see right here. If I set it to be, or sorry, it was just an integer there. Now it's a vector. So if I get the size of that, it is 1 row, 5 columns. If I wanted to get the transpose of it, I just add a apostrophe, get the transpose. If I wanted to multiply this together to get if I wanted to get what does it look like for every element squared, I could try to do this, but what will happen is I get a dimension error because the inner matrix dimensions must agree. So what I'm doing is I'm multiplying a 1 by 5 by a 1 by 5. The inner dimensions are not agreeing, so I have to take the transpose. But that will only give me a 1 by 1, which is basically a scalar, or the dot. It's basically a dot product, because what I'm doing is I'm taking a 1 by 5, multiplying it by a 5 by 1, and you guys should have done matrix multiplication before. It gives me a 1 by 1. So to do element-wise, what I have to do is add a period before the asterisks, and that does element-wise multiplication. So pretty important when we're going to be adding windows, because you don't want to start messing with dimensionality of the. You don't want to start being weird about where should you put the dimensions of a or how to manipulate the dimensions. It's really easy just to do it element-wise, and that's kind of what a window does. Is it's multiplying each of the elements by a certain amplitude. It's kind of how you did the sine wave function as well. So here's what our end product. This is our sine tone with a Hamming window. Since I'm SSH'd in, I can't get the tone. I can get the sound, but I still can plot it. So I generate the tone by using the sine function here. If it's not in this current folder, I won't be able to use the function. So I pull up the sine function. It gives me a helper, so I know that the frequency is 440. The duration is time, and the sample rate is fs, which is 44.1. And I should save this, write this to a variable, and I'll call it tone. And now that should plot. So we'll change here to that. And as you saw in my last video, what we need to do is just plot the first 1,000 samples. So if I plot the time vector, in this notation, what this notation is doing is saying from the first element to the 1,000th element of this vector, and then that's the x-axis, and then the y-axis is here, and I plot that. That should give me that. Cool, looks good. So now to add a Hamming window, I'll do Hamming window. Basically what I did was I went online and I looked up window function Matlab, and it gave me Hamming window. Hamming window basically looks like this. And what you need to do is, there's an example here. You give it the length of your vector, the length of how much you want, how big of a how big the vector is that you're applying the Hamming window to, basically my entire time vector. And then all you do is just say you call the function Hamming on that length. So to do it in Matlab, what we're going to do is we're going to say, okay, my window is equal to Hamming times the length, or the Hamming of the length of an array, which I'm going to say is timevec, which is basically how long our sine tone is in samples. And that should work. Cool. So if we plot the window, that's what it looks like. Cool. All we need to do now is multiply each sample of the sine tone by the sample in the window. So if we do that, all we need to do is multiply tone times window, right? But no, we should get we get one thing, because what we did was tone is 1 by 44.1 and window is 44.1 by 1. So by doing that, we got a 1 by 1 by multiplication. So what we need to do is get these to match up, 1, and then 2, do it element wise. So tone, so if we want the windowed tone to be tone element wise multiplication by the transpose of the window, and then we can plot window tone. And what do we get? The Hamming window. So yeah, so there are a bunch of windows. You can choose whichever one you're really interested in. They all kind of give different properties when we talk about the spectrum. When we start using the FFT function, I think I can just, I'm not going to mess with the FFT right now. But anyway, yeah, so should give you pretty simple, just a couple commands. Hope this works. Please post any questions you have to the Piazza, and I will hopefully just be able to do a text response for it. Okay, thanks.